So now we'll define different things, very similar and very important, and you might hear about if we have some vector quantity, then we can calculate the gradient. Gradient means variation in the main direction, in all direction. And the gradient is a vector quantity. It's like the direction derivative. Vector quantity means it is in a form of vector. So firstly, we can define the directional derivative by this symbol, which is called nabla. We call it nabla, all right? When you read this symbol, which is like a triangle in opposite direction, called nabla f, or gradient f. Gradient f equals the partial derivative of the function f with respect to x times I is a unit vector or basic unit vector in x-axis, plus the partial derivative with respect to y in y direction, or times j. Here we have an example to calculate the derivative of a given function if f of x and y equals y ln x plus xy squared at the given point 1 and 2. The derivative with respect to x, the derivative, when we calculate the derivative with respect to x, will treat y as a constant, then the derivative of ln x equal 1 over x. The derivative of the first term equal y over x, this one, right? And the derivative of the second term with respect to x is just y squared, because again we are treating y as constant, then the derivative of x equals 1, yani plus y squared. And the derivative of the same function with respect to y-axis, in this case, will treat temporarily ln x as constant, and the derivative of y equal 1, then the derivative of the first term equals ln x. And for the second term, we'll treat x temporarily as constant, and the derivative of y squared equals 2y, then it is 2xy. So we have now the two components of the derivative. We'll just go directly and substitute in the definition. And the last step is to substitute x and y by the given point. X equal 1 and y equal 2. So just substitute and do simple calculation. You will get this vector. So the gradient of the function represented by the vector 6i plus 4j.